Today I am going to discuss about carbon compounds related to one paper discussion. We are going to start with first question. Valency and valence electrons of carbon are dash. Consider this is a carbon, atomic number 6, configuration of 2 and 4 is there here. 4 is nothing valence electron. What is the valence electron of carbon? 4. All the 4 valence electron of carbon ready to contribute now. Common electron ready to contribute, that is valency. Carbon able to contribute 4 electron, hence the valency of carbon is 4. Carbon has 4 electron in the outermost shell, hence valency and valence electron is same in case of the carbon. Therefore, the right option is third one is right answer here. I repeat, valency and valence electron of carbon are, carbon atomic number is 6. This is electronic configuration of carbon 2 and 4. Now here 4 is the valence electron and all the 4 valence electron ready to donate, hence its valency also 2. Therefore, valency and valency electrons is same in case of the carbon. Based on this, the right option is third one here. Right? The next one here. Question number 2. Carbon atom to attain the electronic configuration of the nearest to noble gas is. Consider now this is carbon, atomic number is 6, the electronic configuration 2 and 4. And carbon able to contribute 4 electron and others also able to contribute 4 electron. Then the 4 and 4 electron they used to count for contributed atoms or elements here. Then see the now here, carbon able to contribute 4 and other also able to contribute 4 here. Then total how many electron? 2 plus 2 plus. So 4 plus 4 plus 2, this is equals to 10 electrons. 10 electrons is nothing, this is nearest to inert gas is nothing, neon is there here. Then you select now, second one is right options here. I repeat, carbon, atomic number 6, this is electronic configuration of carbon and carbon able to contribute 4, other also able to contribute 4, 4 plus 4, 8, 8 plus 2, totally 10 electrons after contributed 4 electrons. Then once carbon has 10 electrons, which is nearest to the inert gas is that is neon. Therefore, carbon atom to attain the electronic configuration, the nearest noble gas is nothing but you can say neon here. Okay, because atomic number of neon is equal to 10 electrons here. Right? Now next question here. Question number 3. The double covalent bond present in the following species here. The double covalent bond here present in the following species. Between the two nitrogen atom, triple covalent bond present. Hence, this is not correct because they are asking here double covalent bond. You consider oxygen atoms now. Between the two oxygen atom, double bond is there. Hence, this is right options here. Therefore, you select now oxygen here. Once again, between the two hydrogen atoms, single covalent bond. This is also not correct. And between the two chlorine atoms, single covalent bond present here. This is also not correct. Because the question is the double covalent bond present in the following species. Your right answer is oxygen molecule. Between the two oxygen atoms, double bond is present here. Hence, second option is right answer. Right? Next one. Simplest hydrocarbon is, question number 4th one, simplest hydrocarbon. Consider the molecular formula of the following species. Ethane molecular formula C2H6, methane molecular formula CH4, ethene molecular formula C2H4, then propane molecular formula C3, okay, H8 is there here. This is the molecular formula of ethane, methane, ethene and propane. The question is simplest hydrocarbon. The simplest hydrocarbon depend on the number of carbon atoms here. In first case, remember 2 carbon atoms here. How many carbon atom? 2 carbon atom. Second case, only 1 carbon. Third case, 2 carbon atom. In last case, 3 carbon atoms. Then you remember, so less number of carbon atoms in case of the methane. So only one carbon atom present in the case of methane. Hence, this is the simplest hydrocarbon due to presence of one carbon atom here. So which is the simplest hydrocarbon? That is methane due to presence of one carbon atom. Right? Next one. Unique property of carbon. So now, unique property of carbon here. Low ionization energy. Okay. This is not related to carbon. Generally, carbon has high ionization energy and a large size. You know that carbon is a small size. And unique property of carbon, catenation. This is the right answer here. And next one, carbon has low electronegativity. This is wrong. Carbon has high electronegativity. This is wrong. Carbon has high ionization energy. This is also wrong. Carbon has small size, not large size. This is also wrong here. Only the catenation is the unique property of carbon. What is catenation? Nothing but okay. The respective element or atom. The atom is able to form the chain. Atoms able to form the chain of its own kind to form a large chain here in the form of long chain, in the form of ring chain here. Again, in case of the so means open chain, you can say either in the form of straight chain or branched chain here. So generally, carbon in the entire periodic table exhibit the predominant property, unique property, special property of carbon is that is catenation. Why catenation exhibit here? Okay. So why carbon exhibit this property? Due to small size. Due to small size. So because of the due to small size, carbon-carbon bond is very strong, cannot break down so easily. That's why carbon able to form any length of the chain here. Right? And with the stable chain here, with the stable chain due to small size. So therefore, the special property or unique property of carbon is catenation here. Next question here. Unsaturated compound of the following is unsaturated compound. This is important. Compound. Oxygen. This is unsaturated elemental molecule. This is not compound. Oxygen here. Hence, it is not correct one here. You consider between the two oxygen atom, double bond is there, but it is unsaturated. But this is not compound. This is elemental molecule. Hence, this is not correct here. Methane. Between the carbon hydrogen atom, only single covalent bond. This is saturated compound. This is also not correct. N2, between the two nitrogen atom, triple bond present here. Nothing but this is unsaturated elemental molecule. This is also not correct. CO2, between the carbon and oxygen, on either side, double bond is there here. Hence, this is unsaturated compound. Unsaturated compound. Okay. CO2 is the right answer here. Which is right answer? CO2. Now, next question here. The number of bonds present in propane. Number of bonds present in propane. Propane molecular formula C3H8. This is the molecular formula of propane. So now, because of the ANA, between the carbon atom and around the carbon atom, only single covalent bond. Then you can consider 1, 2, this is 3. And around the carbon, 4 single covalent bond you have to arrange it due to ANA compound here. And these bonds, unsatisfied bonds, are satisfied with hydrogen atom here. Like this, you can say it now here. This is the structural formula of propane. Now, question is number of bonds present in propane. See now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonds are there in case of the propane. The number of bonds present in propane is that is 10. Fourth option is right answer here. In this way, okay, you find out the answer with respect to 7th question here. Now, next question. Question number 8. Number of CH2 groups now here. Number of CH2 group in hexane. In hexane. You know that hexane molecular formula. Hexa means you know that now 6 carbon atom ANE, hydrogen double, because general formula for hexane is nothing but CN H2N plus 2 is there here. Based on this, number of carbon atom is 6. H2 into 6, 12 plus 2, you know that 14 is there here. What is this? 14. This is the molecular formula of hexane. What is the structural formula of hexane? You have to arrange it 6 carbon atoms here. Okay, 6 carbon atoms here. And between the carbon atom, because of the ANA, single covalent bond here. Then you can consider now. Remaining 3 bonds satisfied with the 3 hydrogen, 1 2 bond. Remaining 2 bonds satisfied with hydrogen, 1 2 satisfied with 2 hydrogen. It should become CH2. This is CH2. This is CH3. They are asking about number of CH2 group. This is one CH2 group, second CH2 group. This is third one CH2 group now here. This is third CH2 group now here. Okay, and this is fourth CH2 group. But they are asking about only number of CH2 group here. And how many are there? 1, 2, 3, 4 are there. 4 CH2 groups present in hexane compound. So the 4 is there in case of the second options here. The number of CH2 group in hexane is 4 here. Suppose in the same question, the number of CH3 groups in hexane, you should know the structural formula of the hexane, then you are going to get number of CH3 group. This is 1 and this is 1 here. Then your answer is 2. Suppose in case of number of CH2, number of CH3 there, your answer is only 2. But now question is number of CH2 group. CH2 group is also known as a methylene group. What is called? CH2 group, nothing but a methylene group. How many are there methylene group? 1, 2, 3, 4 here. Therefore, second option is right answer here. Question number 9. Molecular formula of cyclohexene and cyclohexane here. Molecular formula of cyclohexene and cyclohexane. Cyclo means a ring compound here. What is this? Cyclo nothing but a ring compound here. You know that now? This is the structural formula of the cyclohexane here. Okay, En means one double bond should be present here. Then you remember here, this is one carbon, second carbon, third, fourth, fifth, sixth. Nothing but you can say 1, 2, 3, 4. Now this is 5 and this is 6. 6 carbon atoms here. 1, 2, 3, fourth bond with hydrogen. 1, 2, 3, fourth bond with hydrogen. Only one. Remaining 2 bonds satisfied with hydrogen. Satisfied with the 2 hydrogen here. See the now here. Hydrogen is there. This is the structural formula of the cyclohexane. Then how many hydrogen atoms are there? Check it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is the molecular formula of cyclohexane. Like this, you should know cyclohexane structure here. Hexane means this is a ring structure now here. This is called cyclohexane. Nothing but I can say at every corner of the cyclohexane carbon atoms are there. 1, 2 on either side of the carbon atom, remaining 2 bonds satisfied with the 2 hydrogen atom. 2 hydrogen atoms here, like this here. Correct? Hydrogen here. So now here, how many carbon atom in this cyclohexane? 6 carbon atom. Then how many carbon atom? 6. How many hydrogen atom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 are there here. This is the molecular formula of cyclohexane, C6H10 and C6H12. This is the molecular formula of cyclohexane. Then where it is there? The right option is nothing but you can say third one here. This is the C6. In case of the third one, C6H10. This is the molecular formula of cyclohexane. C6H12. This is the molecular formula of the cyclohexane. Right? So this is the answer regarding 9th question here. Question number next one. Number of CH bonds in case of the benzene. You know that the benzene molecular formula C6H6. This is the molecular formula of benzene. You should know benzene ring structure here. This is one carbon, second carbon, this is third one, now this is fourth, now this is fifth, and this is sixth one here. Okay. Then next one, 1, 2, because carbon has a tetravalence nature, 1, 2, this is the third one now here. Because in case of the benzene, double bond, single bond, double bond, single bond, okay. Now again double bond, single bond. So in this way, in case of the benzene, double and single bond which are arranged alternatively. So to satisfy the tetravalence nature of the carbon, around each carbon, shortage of one bonds, 1, 2, 3, the fourth bond with hydrogen, 1, 2, 3, the fourth bond with hydrogen, 1, 2, 3, fourth bond with hydrogen. Then you have to arrange it like this here. This is the structure of benzene. Question is number of CH bonds here. Check it now. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Now here 16 are there. How many are there? Number of CH bonds. This is the total number of the bonds. But particularly they are asking about number of CH bond here. Then check it now. This is one CH bond, second CH bond, third CH bond, fourth one CH bond, fifth one CH bond, and now this is sixth one CH bond here. Now your answer is, okay, number of CH bonds in benzene is 6. That is there in first option here. So number of CH bonds, how many are there? 6 are there here. Suppose, okay, similarly, in case of the benzene, how many carbon-carbon double bonds means your answer is 2. This is one carbon-carbon double bond, second one, this is the third one. That is also, you just remember here, okay? So this is the answer regarding 10th question. Number of CH bonds in benzene, your answer is 6. Nothing but that is first option is right answer here. Now next question here. The functional group of aldehyde. So in my previous classes, we have studied functional group is nothing but a single atom, a group of atom which decides the chemical properties of the respective substance or organic compounds, you can say, which decide the chemical properties of the organic compound. Functional group is one of the example of, okay, functional group here. The structure of functional group as follows. First one is the ketone functional group. Now this is ketone functional group. They are asking about aldehyde. This is not correct. This is alcohol functional group here. This is also not correct. Now this is aldehyde functional group here. This is aldehyde functional group. Hence third one is right option here. The fourth one is carboxylic acid functional group here. What is this? Carboxylic acid functional group here. This is also not correct here. Only third one is right answer here. Remember? So now single bond CHO. You can write it. This is in the form of carbon oxygen always a double bond. Now this is the structure of CHO. This is structure of CHO, right? This is a just okay functional group. This is the structure of the functional group of CHO. This is about the functional group of aldehyde CHO here. Okay. Now next question. COH is the functional group of dash. Already we said in the previous question, 11th one. Aldehyde functional group is CHO like this. Single bond COH here. Single bond COH is the functional group of dash here. Alcohol functional group single bond OH is there. What is this? Single bond OH. This is the functional group of alcohol. Aldehyde single bond CHO. This is the functional group of aldehyde. Ketone functional group single bond CO. Now this is CO is there. Carboxylic acid. Carboxylic acid functional group is okay single bond COH is there. This is the unsatisfied bond. See, on one side, on either side, free bond is nothing but unsatisfied bond. So those bonds always satisfied with either alkyl or aryl group here. Now they are asking about here, okay, unsatisfied bond with the COH is nothing but a functional group of carboxylic acid. Therefore, fourth one is right option here. Now next question here. Any two successive compounds of a homologous series differ by dash. Any two members of homologous series. Suppose if you consider alkane, this is the one homologous series here. Question is now any two successive compounds. Nothing but you can say first member of alkane is the methane. Successive compound next one is ethane. Difference is there here. C2 minus C1, nothing but one carbon left. H6 minus H4, remaining CH2. This is the difference. This is the difference here. Nothing but any two successive compound, remember, of a homologous series always differ by the okay CH2 group. The CH2 group is nothing but a methylene group here. What used to call? Methylene group used to call here. Not only in this series, you take next series also. Alkyne. The first member of alkyne is ethane. Ethane means you know that C2H2 is there. Because alkyne general formula CN H2n minus 2. That's why your number of carbon atom minimum 2. So if you are going to substitute n equal to 2, then you are going to get first member of alkyne member of molecular formula. This is what used to call, this is ethane. Next one after ethane, propine. Next successive member is propine. Propene is how many carbon? C3 there. Double minus 2, nothing but H4 you are going to get. The difference between these two successive compound is what now? CH2 group is there once again here. Because C3 minus C2, nothing but 1 carbon, H4 minus H2, nothing but H2 is left now here. So in any homologous series, either alkane or alcohol or carboxylic acid or esters or ethers, in any kind of the homologous series, difference between the two successive compounds always with the CH2 group. CH2 group nothing but a methylene group. Then where it is there? That is there in case of the second option here. Second one is right answer here. Two successive members differ by a CH2 group here. Now next question. Next successive compound of ethyl alcohol here. Next one, not previous one. Now check it now. C2H5OH. This is the second member of alcohol family. This is the one series is alcohol series. Alcohol series here. First member is methyl alcohol. What is the second member? Ethyl alcohol. CH3, CH2OH. Otherwise, you can write this one in the form of C2H5. Next to successive compound C3, then you can write it. C3, CH3, CH2, CH2, then OH. Together, what you used to call this is C3H. How many are there here? Then you can say C3H7OH. Propyl alcohol used to call here. Propyl alcohol. Then what is the next successive compound of ethyl alcohol? The next successive compound of ethyl alcohol is propyl alcohol. The molecular forms of propyl alcohol C3H7OH. Where it is there? Third one is right options here. So now next successive compound of a C2H5OH ethyl alcohol is, what is the answer? Now your answer is nothing but C3H7OH. This is the molecular formula of propyl alcohol. Otherwise, you can say propanol here. Okay. Next one here. Functional group which determines the properties of organic compound is dash. Functional group which determines the properties of organic compound is. So, functional group which determines what properties here? Predominantly chemical properties. Which one? Chemical properties. Functional group which determines the chemical properties of organic compound. Hence, you select now first option here. In generally, suppose if you consider R, CH2. Now this is called OH. This is called as alkyl group. What is to called? Alkyl group. Alkyl group which decide the physical properties. Functional group which decide the chemical properties. Same answer in case of the aldehyde functional group here. This is aldehyde functional group. This CHO group which decide the chemical properties, or this is alkyl group which decide the physical properties. But question is functional group which determines the properties of organic compound is dash. Your answer is chemical properties here. For functional group always decide the or determines the chemical properties of the respective organic compound here. Okay. Next question. General formula of alkene. What is the question? General formula of alkene is. So alkene general formula. Now see now CnH2n. This is the general formula of alkene. Alkene here. Suppose in place of Ene, if Ene is there, CnH2n plus 2. This is the general formula for Ene compound. General formula for Ene compound here. What is this? This is the general formula of Ene compound. Similarly, suppose now CnH2n minus 2 is there. This is the general formula of alkene compound. This is. Anyway, CnH2n, this is alkene general formula. CnH2n plus 2, this is alkane general formula. What is this? Ane, alkane general formula. CnH2n minus 2, this is general formula for alkyne. But the question is, general formula of alkene is CnH2n. Where it is there? In first option it is there. Hence, First option is right answer here. Okay, next question here. Suffix for alcohol. See now here. End of the compound suffix nothing but suffix for alcohol. Alcohol is one of the functional group. Okay. So always you know that first one generally while writing the IUPAC name root word used to return root word RWO. Then what used to return suffix part should be written here. In case of the suffix, so two parts are there here. One primary suffix and one more secondary suffix is there. What is this? Secondary suffix here. Secondary suffix related to okay functional group here. Secondary okay suffix related to functional group. Suppose if you consider alcohol here. So in alcohol consists of first root word followed by the okay ane is the primary suffix. What is this? Ane is nothing but a primary suffix here. And the next one end with the secondary suffix is there. What is this? Secondary suffix. Secondary suffix is related to functional group. We can say it here. Functional group here. So the suffix for alcohol is OL. Hence the he is replaced by OL here. Therefore, we are going to get now alk. Okay. AN. This is the root word and this is the primary suffix. Because of the alcohol is the functional group, hence the he is replaced by this e there, no, this e is replaced by always okay. In case of the alcohol, OL you can say now, alconol. Then what is this? Alconol here. Therefore, suffix for alcohol is OL here. Third option is right answer. So now AL is the suffix for aldehyde. This is the suffix for aldehyde. ONE is the suffix for ketone. AL is the suffix for alcohol. Oic acid is the suffix for carboxylic acid. What is this? Carboxylic acid. But what is the question? Suffix for alcohol means that is OL. Third option is right answer. 17th year. Next question. Suffix for YNE. In case of the alkyne, this is root word. What used to call? This is root word. And the next YN is nothing but a suffix. YN is nothing but a suffix. Generally used to call this is the primary suffix. This is the primary suffix here. You can't get a secondary suffix in case of the ANE, ENE and YNE. Then you decide. This is nothing but a suffix for alkynes. What is the suffix for alkyne? YNE. Therefore, third one is right answer here. 18th, third one. Now, next one here. Question number 19. The 19th question, number of hydrogen atoms in propene. In propene here. Propene, it belongs to the alkene family. Nothing but a alkene, nothing but a general formula CnH2n. Prop, nothing but a number of carbon atom, nothing but n equals to 3. Substitute in this general formula for alkene. Then you are going to get C3H2 into N is nothing but 3. Then you are going to get C3S6 will get it. So now question is number of hydrogen atom present in propene. This is the molecular formula of propene. In this molecular formula of propene, the number of hydrogen atoms, how many are there? 6 are there. How many are there? 6 are there. The option, okay, now second one. The second one is the right answer here. Okay. So now sometimes the number of bonds present in propene also you should remember here. So number of number of bonds present in propene. Then in such cases now we can take structure here because of the it is a ENA compound between the first two carbon double bond. Tetravalence in nature 1 2 third bond and fourth one with hydrogen 1 2 3 fourth bond with hydrogen 1 okay second bond with hydrogen third bond with hydrogen fourth one with hydrogen. In place of hydrogen atom number of bonds means how many are there 1 2 3 4 5 6 7 8 okay 9 bonds are there. How many bonds? 9 bonds are there in case of the propene. But question is number of hydrogen atom. Hence, the right answer is okay. Second option, which consists of 6 are there here. In this way, you decide the answer with respect to this question here. Next one. Number of structural isomers for pentane. See now, any area. Number of structural isomers for pentane. Pentane, okay. Molecular formula pentane C5 H double plus 2, because general formula for pentane CnH2n plus 2. Hence molecular formula C5 H12 you are going to get. This is the pentane. Number of structural isomers how we are going to get now. Pentane has 3 structural isomers. How many? 3 structural isomers here. 3 structural isomers. One is normal chain. What used to call normal chain in the form of N-pentane. See, N-pentane molecular formula as it is C5H12 there. Now you have to arrange it. Normal means you know that all the 5 carbon atoms should be arranged in straight line here. Okay. Then now remaining 3 bonds satisfied with the 3 hydrogen. 1, 2, CH2, 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 CH3. So this is the okay. One of the structure of the N-pentane. In case of N-pentane, all the 4 carbon atoms arranged in a straight line. This is one structural isomer. Second one, isopentane. Isopentane. In this case, molecular formula is same, C5H12. See now, out of 5 carbon atoms in straight line, you have to arrange 4 carbon atoms. Other than first and last, 1 carbon has a branch. Hence, now this condition is iso condition. It should become CH3, CH, CH3, CH2. Now this is CH3. This condition is nothing but iso. Here also 5 carbon atom and here also 5 carbon atom, but arrangement of the carbon chain is different here. So now this is the N chain, this is iso chain is there. Iso chain nothing but other than first and carbon, 1 carbon has 1 branch. This is iso condition here. And the next one, if you consider third one here, right? The third one is neo. What you used to call neopentane. Neopentane here. Molecular formula C5H12 here. So in this case, you have to arrange 3 carbon atoms in straight line. Now, other than the first and last, this is center carbon has 2 branch. This condition used to call neo. Now, this becomes CH3, 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 CH3. See now here, 2 or more compounds having same molecular formula, here. See, 1, 2, 3. Okay, these are the compounds having same molecular formula, but differ in the carbon chain. In first case, all the carbon atoms in straight line. In second case, okay, only 4 carbon atoms are in straight line. In third case, only 3 carbon atoms are in straight line here. In second case, 1 branch. In third case, 2 branches on 1 carbon atom. Hence, you are going to get a different structural isomers in the form of N-pentane, isopentane, and neopentane. Then pentane has how many structural isomers? 3 are there. Then second option is right answer here. Next one, molecular formula of propanone. Molecular formula propanone. ON is there here. This is ketone. This is example for ketone family. This is example for ketone family. Okay. Molecular formula propanone. Propanone is example for ketone compound. Prop is nothing but you can remember C3 there here. Prop is nothing but C3. AN nothing but you can say. Okay. Now yeah, H6 is there here. ON means it's a ketone group. This is nothing but O. Because they are asking about molecular formula C3H6O. Otherwise, you can say how we are going to say C3H6O structural formula. Prop means how many carbon? 3 carbon. And one of the carbon atom has functional group, which is non-terminal functional group, that is called CO. Then remaining carbon atom linked with a single bond here. 1 now here. Otherwise, you can say carbon, oxygen always linked double bond here. One bond, remaining 3 bonds satisfied with hydrogen. Now we already satisfied. Now here, last carbon atom. Now remaining 3 bonds satisfied with the hydrogen atom. Then in this molecular formula, how many carbon atom? 1, 2, 3, like this. How many hydrogen atom in this structure? 3 plus 3 hydrogen, 6 are there. In this structure, how many oxygen atom? 1 is there. Hence, it is a molecular formula. Then what is the molecular formula of propanol? C3H6O. This is structural formula. This is molecular formula. This is molecular formula. This is structural formula. So the question is molecular formula. Hence you select now this one here. Where it is? It is there in first option here. It is there in first option. Now next one. Combustion is a dash process is there. Combustion is dash process. Remember, any species containing carbon generally, right? One or more carbon atom or alone carbon atom, it burns with oxygen of air. Combustion means at suitable temperature, always to form water, H2O, and large quantity of heat and light liberated. What I am saying? Large quantity of the heat and light liberated. Hence, this process is always exothermic. Liberation of heat, what used to call? Exothermic process here. Any oxidation or oxidation, another name is a combustion. Combustion or oxidation is always exothermic process because of the large quantity of heat liberated. Therefore, first option is right answer with respect to 22. Next one, 23. Oxidation product of CH3, CH2OH. Oxidation product of ethyl alcohol. What is this? Ethyl alcohol here. Then you can say CH3, CH2OH. This is an oxidation. This is an oxidation. By using oxidizing agent like acidified potassium permanganate or potassium dichromate here. See, potassium dichromate, potassium permanganate. Anyone you can use. What is the role of this in acidic medium? So this is about the supply of oxygen atom. Then remember, addition of oxygen and removal of hydrogen. Then alcohol becomes CH3COOH. And this excess of hydrogen lost in the form of water here. What you are going to say? In the form of water here. In the form of water, you can say it. The excess of hydrogen lost in the form of water. Then what is oxidation? Addition of oxygen, removal of excess of hydrogen. See, in place of 2 hydrogen, 1 oxygen atoms are added. And here, simultaneously 2 hydrogen atoms are lost in the form of water here. Then addition of oxygen by any substances used to call the oxidizing agent. Now in this case, in presence of acidic medium, either potassium dichromate or potassium permanganate act as oxidizing agent because both are ready to supply the oxygen. So then, the substance like alcohol undergo oxidations here. Then tell me, oxidation product of ethyl alcohol is nothing but acetic acid. What is the structure of this is? This is used to generally called the acetic acid here. Where it is there? This molecular structure here. Second option here, CH3COH here. I repeat once again. This is the ethyl alcohol. This is an oxidation by using of either acidified or alkaline medium of potassium dichromate or potassium permanganate as oxidizing agent. Normally, oxidizing agent which supplies oxygen responsible for the removal of hydrogen. Then in place of hydrogen, oxygen atoms are added. Hence, used to call the oxidation here. The oxidation product of ethyl alcohol is acetic acid. The molecular formula of acetic acid is CH3COOH. So, second one is the right option for question number 23. Next one. Characteristic reaction of unsaturated hydrocarbons. So now, characteristic reaction of unsaturated hydrocarbons. Unsaturated nothing between the carbon atom, double bond or triple bond may present here. This is unsaturated and this is also unsaturated. And wherever multiple bond is there, one strong bond sigma bond, one weak bond is a pi bond. Wherever triple bond is there, one is a strong bond is sigma bond, remaining two are weak bond here. So pi bond is weaker. That's why in place of the pi bond, because pi bond at the reactive nature here. So that's why in place of pi bond, other species are added here. So other species are added in place of pi bond. We used to call it the addition reaction. Remember, characteristic reaction of unsaturated hydrocarbon like either alkene. What is this? This is called alkene, unsaturated hydrocarbon. This is alkyne. This is alkyne. In both the case, remember, okay, pi bond is present along with the sigma bond in the form of double and triple bond. So because of that, due to presence of double and triple bond, they used to undergo addition reaction as important characteristics of the unsaturated hydrocarbons here. Then what is the answer? Characteristic reaction of unsaturated hydrocarbon is addition reaction. Cannot undergo substitution, elimination, rearrangement reaction. Only it undergo addition reaction due to presence of multiple bond which consists of pi bond. You can say particularly pi bond is replaced by the by other species. Next question here. Question number 25. Chlorination of methane in the presence of sunlight is an example of what here? Chlorination of methane. Methane, this is related to saturated hydrocarbon. What is this? Chlorine is nothing but a saturated hydrocarbon. Otherwise, you can say another name, alkane compounds here. Any compound means saturated compound here. So methane cannot undergo addition reaction because around the carbon only single covalent bonds. Only one or more hydrogen atoms replaced by the chlorine or any other species. But the heading is chlorination is the area. Nothing but when methane react with chlorine in the presence of sunlight. Suppose in limited supply of oxygen, one hydrogen replaced by one chlorine, you are going to get methyl chloride plus HCl is the byproduct here. Plus what? HCl is the byproduct, you can say it now here. This is methane, saturated hydrocarbons like alkane. So when methane react with chlorine in the presence of sunlight, one H replaced with one Cl, then you are going to get methyl chloride. Byproduct is HCl. Suppose the same reaction. This is called methane. This is the first member of alkanes, which is saturated hydrocarbon. When react with excess of chlorine, this is called excess. In presence of sunlight, how many hydrogen atoms? 4 hydrogen atoms are there here. How many? 4 hydrogen atoms. All the 4 hydrogen atoms replaced by chlorine. Then you are going to get, remember, carbon tetrachloride. And those 4 hydrogen atoms lost in the form of 4 molecule of HCl. 4 molecule of HCl. So final product, the compound contain chlorine. So in this case, 1 chlorine, in this case, 4 chlorine. So because of the excess of the chlorine here. So means in both the ways possible, when chlorine react with the limited supply of chlorine, in the presence of sunlight, you are going to get methyl chloride. The same reaction, if you are going to carry out in the presence of excess of chlorine, then carbon tetrachloride you are going to get, carbon tetrachloride. So now this is a replacement reaction. Hydrogen replaced by other species because other species are more reactive than hydrogen. So that's why characteristic reaction of any alkane compound, including methane, is related to always substitution reaction here. Substitution reaction, one more name, replacement reaction. Replacement reaction this is. Chlorination of methane in presence of sunlight is an example of what? Substitution reaction. This is the characteristic reaction of the alkane compounds, including methane. Now, next question here. Widely useful alcohol. What is this? Widely useful alcohol here. Means more useful alcohol, you can say it now here. Methanol is harmful generally, right? It's not widely useful. Propanol it cannot be prepared in large quantity. It is less useful. Ethanol is the right answer here. Ethanol is more useful as solvent, as power alcohol, as fuels, and as beverages alcohol. Like this, ethanol are more useful when compared to others here. Ethanol used as a laboratory agent Ethanol used as a solvent for various substances. Ethanol used for preparation of the alcoholic beverages. Ethanol used for preparation of many other substances as solvent. Therefore, ethanol is the most widely useful alcohol when compared to others here. Now, next question here. The next question here. Okay. The next one. This is a question number 27. This is the ethyl alcohol. When react with the sodium metal, what is this? This is called sodium metal. This is sodium metal, you can say it here. So react with the sodium metal here. What is this? Sodium metal. Then what is the A and what is the B there here? Check it now. This is ethyl alcohol when treated with the sodium metal Na. Sodium metal Na. Sodium is more reactive than hydrogen. This is the polar nature. In case of ethyl alcohol, OH group is the polar nature. This is minus, so this is plus. While reaction time, sodium has a plus charge by losing one electron. Sodium plus charge is stronger than H plus ion. Then you can say in place of hydrogen, sodium metal interior. This is displacement reaction. Sodium metal which can displace the H plus ions of the OH group of alcohol. Then you are going to get sodium ethoxide. What used to call sodium ethoxide. Then this H plus is lost in the form of hydrogen gas here. Now you can say now this is O2 in balanced equation. So now tell me, when ethyl alcohol on reaction with sodium, then you are going to get this sodium ethoxide. Now this is called a sodium ethoxide with the liberation of which gas? Hydrogen gas in this case here. Then tell me the product of A and B. This is A and this is B. The A is this one here. What is the B? Hydrogen gas liberated. Hence you select now. Second one is right options here. This is one of the chemical property of the alcohol. This chemical property related to acidic nature, because we know that now ethyl alcohol provides the H plus ion, that's why it is acidic nature. What is this nature? This is acidic nature of alcohol here, acidic nature here. So in place of H plus ion, sodium ions, substituted. Then you are going to get A product is sodium salt of ethoxide with the liberation of the H2 gas. The H2 gas is nothing but B. So therefore, the second one is right answer here. Now next one. Question number 28. Heating of ethanol at 443 Kelvin with excess concentrated sulfuric acid to form product which is dash is area. To form the product which is. Now consider now. This is the ethyl alcohol CH3, CH3, CH2, OH you have to write it like this here. And this CH3 you have to write for our convenience CH2 and one of the H is write it like this here. When treated with concentrated sulfuric acid, excess of concentrated sulfuric acid, in this reaction, concentrated sulfuric acid act as dehydrating agent which is responsible for elimination of water from the adjacent carbon atom of the ethyl alcohol. Elimination of water is the one of the product. Then what will happen here? So now hydrogen is lost, C carries minus charge. OH is lost, then this C carries a plus charge. Minus charge is excess of electron responsible for the formation of the pi bond. Then you are going to get CH2 double bond CH2. Its molecular formula C2H4. The name of this product is nothing but used to call the ethene. What used to call ethene? Then you remember, when ethanol, this is called ethanol or ethyl alcohol, Okay, we are going to heat at how much temperature? 443 Kelvin. This is a special temperature. At this temperature, okay, concentrated sulfuric acid act as a dehydrating agent, which is responsible for the elimination of water from the adjacent carbon atom. Then you are going to get, okay, ENE compound. What compound? ENE compound. The name of this ENE compound nothing but ethene. Then where it is there? That is there in second options here. Ethene. Now question number next one.